Hi, my name is Kennedy Smith, and today I'll be talking about relative humidity and evaporative cooling and why humid weather feels different than dry weather. So most of us have experienced a hot summer day, but sometimes the weather feels much hotter than the temperature shown on a thermometer. A big reason for this is because of humidity. Humidity affects how well our bodies are able to cool themselves down. In this presentation, I will explain what relative humidity is, what evaporative cooling is, how sweat cools our body, and why humidity changes the way hot weather feels. So first, let's talk about relative humidity. Relative humidity is the amount of water vapor currently in the air compared to the maximum amount the air can hold at that temperature. It is expressed as a percentage. For example, if the relative humidity is 50%, the air is holding about half of the water vapor it can hold. If the relative humidity is 100%, then the air is completely saturated and cannot hold much more water vapor. In the image on the right, you can see water vapor rising from liquid water. Water vapor is simply water in its gas form. When humidity is low, there is less water vapor in the air. When humidity is high, there's more water vapor already present in the atmosphere. Next, evaporative cooling, and evaporation happens when liquid water changes into water vapor. This process requires energy. That energy comes from heat in the surrounding environment. As water evaporates, it absorbs heat energy and carries that energy away. The image on this slide shows an evaporative cooling system. Warm air enters the system and passes through a wet surface. As the water evaporates, heat is removed from the air, causing the air to leave the system to be cooler. The same process happens naturally all around us and is one of the most important ways that our bodies can stay cool. So, how does sweat cool our bodies? When our body temperature rises, sweat glands release water onto the surface of our skin. As shown in the diagram, heat from inside the body moves towards the skin. When the sweat evaporates into the air, it takes some of that heat energy with it. This is why sweating helps us prevent us from overheating. The photograph on the slide shows the sweat surface on the skin, while the diagram shows what is happening underneath it. The sweat itself does not cool us. The cooling occurs when the sweat evaporates and changes into water vapor. Now let's compare dry weather and humid weather. In dry air, sweat evaporates quickly because there is not much water vapor already in the atmosphere. The air has room to accept more water vapor. Because sweat evaporates quickly, heat is removed from the body more efficiently, making us feel cooler. In humid air, the atmosphere already contains a lot of water vapor. Since the air is nearly full, sweat evaporates much more slowly. As a result, less heat is removed from the body, and we feel hotter and more uncomfortable. This is why the same temperature can feel very different depending on the humidity level. We could see this effect in different parts of the U.S. Arizona is known for having a hot but really dry climate. Even when temperatures are very high, sweat can evaporate very efficiently because the humidity is low. Florida, on the other hand, is both hot and humid. Because the air already contains a lot of water vapor, sweat does not evaporate as well. The map on the right shows average humidity levels across the country. You can notice that many southeastern states tend to have higher humidity levels than the southwestern states. The heat index chart on the left also demonstrates this relationship. As humidity increases, the temperature can feel much hotter than the actual air temperature. For example, a temperature of 90 degrees may feel closer to 100 degrees or more when humidity is really high. So you could try this yourself if you want to. Here's a simple activity. Place a small amount of water on one hand and leave the other hand dry. Then blow like a fan or air across both hands, and then the wet hand should feel cooler than the dry hand. This happens because the water on your skin is evaporating and removing heat energy from your hand. This simple activity demonstrates the same process that helps cool our bodies when we sweat. In conclusion, relative humidity and evaporative cooling play an important role in our daily lives. Relative humidity measures the amount of water vapor in the air, while evaporative cooling occurs when water changes from a liquid into a gas and removes heat energy. Our bodies rely on evaporative cooling through sweating to regulate temperature. However, when humidity is high, sweat evaporates more slowly, making it harder for the body to cool itself down. This is why humid weather often feels much more hotter than dry weather, even when the temperature is exactly the same. Thank you for watching.